Hello, my name is Lumbu and today we are going to look at traversal computations. At the end of this lesson, you are supposed to be able to do the following: to calculate and adjust angular closure, to calculate the whole circle bearing for each traversal leg, and students should also be able to determine the change in eastings and change in northings. And again, calculate and adjust the total error in the change in northings and change in eastings, and also do the arithmetic check, and also do the coordinate calculations. Of course, for the coordinate calculations, we are going to look at this at our next discussion. So for today, we are going to stop at the errors in the change in eastings and change in northings. As for the area, we're going to look at that at our next discussion. So before you start any traversal calculations or traversal computations, you're supposed to look at the angular check for the polygon that you've just surveyed. In fact, the total sum of the closed polygon for a traversed area is supposed to add up to n minus 2 times 180 degrees, where n is the number of the sides or the number of angles in a polygon. So let's imagine we have this polygon on our right hand side, and then it is required that we should work out the angular check, or to find out whether the angles in the internal angles of the polygon are going to add up to the formula that we have, n minus 2 times 180 degrees. So the surveyed angle A is 31 degrees 27 minutes and 07 seconds. Angle B is 210, so angle B is that angle, that is the reflex angle. So it's 210 degrees 15 minutes 36 seconds, and angle C is 97 degrees 10 minutes and 48 seconds. Angle D is 73 degrees 36 minutes and 7.2, so that's supposed to be 7.2 seconds, not as it is appearing, but it's 7.2 seconds. And then we have angle E, which is 127 degrees 30 minutes and 18 seconds. So if we add all those internal angles, they are supposed to give us a total which is equivalent to n minus 2 times 180 degrees. So whenever you're adding these angles on the calculator, the symbols for the angle is that where you see the 3 commas and also a 0 there. So this is the symbol for the angle whenever you are calculating. So for example, if you want to dial in, you want to punch in 97 degrees 10 minutes and 48 seconds. So what you do is you punch in 97 degrees, so degrees you punch in on that, and then you punch 10, and then you punch that symbol, that key, and also 48 you punch that key, then you say plus the other angles that you will be working on. So in these cases we have 5 angles. It is a polygon of 5 sides. It means that for n we are going to substitute 5. So we have 5 minus 2, which is equal to 3, and 3 times 180 it is going to give us 540 degrees. So whenever we're adding these internal angles, the total sum is supposed to be 540 degrees. Otherwise we may need to do some adjustments. So this is the addition of the angles in this table that you can see. Angle A, we have that one, angle B and angle C, angle D and angle E, we have that. So as for angle D, we just corrected the seconds to 07 seconds, so that's why you don't see 7.2 on the second side. So what you do, you are going to punch in for angle A, you are going to punch in 31, then that key degree 27 key degree and 0.7 that key degree. Then you say plus 210, and also you'll be punching that, and then you say plus, you have 97, you say plus 97 degrees 10 minutes 48 seconds plus 73 degrees 36 minutes and 07 seconds, then 127 degrees 30 minutes and 18 seconds. So the total, so the total sum is going to be 539 degrees 59 minutes and 56 seconds. So you can see that we are short of some seconds for us to have 540 degrees. So this gives us the error is the required sum minus total observed angles. So in this case is 540 degrees minus the calculated angles that we have calculated from the internal angles of a polygon, which is 539 degrees 59 minutes and 56 seconds. So the answer is going to be minus 00 degrees 00 minutes and 04 seconds. So it means that we are short of 4 seconds for us to have 540 degrees. So the adjustment in this case, that is supposed to be proportional, that to distribute the errors equally. So we divide the error by the number of sides, or by the number of angles that we have. So therefore, in this case, it appears that we are going to add 0 degrees 0 minutes and 0.8 seconds for each and every angle that we've observed. But since we do not want fraction seconds, so we just look at 4 crucial angles, so we just leave one. So we are going to add 1 second to 4 crucial angles, those angles that we think we might have problems in observing them, especially the angles that are acute, sometimes are difficult to observe. So those are the ones that will be considered for adding a 1. So if we add, in fact, for angle A, we have 37 degrees 27 minutes and 07 seconds. So if we add a 1, then we will have the adjusted angles on the other side. But in this case, I'm showing the angles that we have, that is those angles, erroneous angles, and the adjustments that we are going to undertake. Like for angle A, we have an adjustment which is 0.1 second. So if we add 31 degrees 27 minutes and 07 seconds, is going to give us 31 degrees 27 minutes and 08 seconds. And for angle B, we are not adding anything to angle B, because we have just selected 4 angles that we are going to add 1 second. So angle B will remain as it is, and the angle C is 97 degrees 10 minutes 48 seconds plus 0.1 seconds. Then it's going to give us 97 degrees 10 seconds 49 is 97 degrees 10 minutes and 49 seconds. And angle D now becomes 73 degrees 36 minutes and 08 seconds, and the angle E comes to be 127 degrees 30 minutes and 19 seconds. So if we add all these angles, the adjusted angles, the answer is exactly 540 degrees. So in this case, we have adjusted the angles, we have adjusted the internal angles. Now we are ready for the next stage. So if we look at the corrected angles, now the next stage we are going to use the corrected angles. We are not going to use those erroneous angles, but we are going to use the calculated corrected angles. So the corrected angles will appear as it is in this diagram. So now we are ready to calculate the whole circle bearings over the figures. Since we have already been given the whole circle bearing for AB, which is 262 degrees, we are therefore going to concentrate on the whole circle bearing for the traversal legs BC, CD, DE, and EA. So if we look at the whole circle bearing for BC, so as you can see, we have the whole circle bearing for the line AB, and angle A, in that case this angle A is 98 degrees, and angle B is going to be 180 degrees minus angle A, because these are allied angles. So assuming that those north lines are parallel to each other, therefore the line AB is the transversal. So A plus B is equal to 180 degrees, therefore A is equal to 98, therefore B is equal to 180 degrees minus 98 degrees. So this is going to give us 82 degrees. So B is equal to 82 degrees. The purpose of finding the value of angle B, since we are determining the whole circle bearing of the line BC, we need to determine this value and the internal angle of B. If we add these two angles, they are going to give us a tan of this line. That is, if you are sighting C from B from the north, that is you first of all face the north, and then you turn by that angle to sight C. So in order to determine this angle which shows that arc arrow, or maybe which has got that annotation, we are supposed to find the value of B, and then we add with the internal angle. So the value for B is 82. This 82 is added to 210 degrees 15 minutes 36 seconds. So if we add those two angles, then it's going to give us 292 degrees 15 minutes and 36 seconds. So that's the whole circle bearing for BC. The whole circle bearing for BC, once again, is 292 degrees 15 minutes and 36 seconds. For this, we are now ready for the whole circle bearing of the line CD. So there are certain things that we also need to work out for us to determine the whole circle bearing for the line CD. So the whole circle bearing for the line CD is this angle, that is angle D plus the internal angle C. So we have the internal angle. For us to determine the value of angle D, we need to work out the value of angle C, so that we are going to subtract, or if we add D plus C, it's going to give us 180 degrees, which are allied angles. So since we have already determined the value of or the value of this angle, or the whole circle bearing of BC, which is 292 degrees 15 minutes and 36 seconds, therefore it is easy for us to determine the value of angle C, because this angle of the whole circle bearing of this line and angle C, they are angles at a point and they add up to 360 degrees. So to determine the value of angle C, we are going to subtract 360 degrees minus whole circle bearing of the line BC. So if we carry out the subtraction, the answer is going to be 67 degrees 44 minutes and 24 seconds. Therefore, we've determined the value of angle C. So it is easy for us to determine the value of angle D. This angle D is not the whole of that arc, but it's only that angle. So the value of angle D is going to be 180 degrees minus angle C, or in other case 180 degrees minus 67 degrees 44 minutes 24 seconds, because these are allied angles and these north lines are parallel to each other, and the line BC is the transversal. So therefore, if we subtract, the answer is going to be 112 degrees 15 minutes 36 seconds. In order to determine the whole circle bearing for CD, that is from the north, so in this case, in all the lines, the arrows indicate the direction of the north, or indicates the position of the north, though I haven't indicated in other lines. So where we have the arrow, that's where the north point is. So if we turn from the north facing D, then we're supposed to add this angle small letter d plus the internal angle C, which is 97 degrees, 10 minutes and 49 seconds. So the whole circle bearing of the line CD is going to be 97 degrees, 10 minutes 49 seconds plus 112 degrees 15 minutes and 36 seconds, and the answer comes to 209 degrees 26 minutes and 25 seconds. So that is the whole circle bearing for the line CD. Now we are going to work out next the whole circle bearing for the line DE. So to determine the whole circle bearing for the line DE is going to be this angle G plus the internal angle of D. So to work out the value of D, we need to determine the value of E, because that angle and angle E and angle G, these are alternate angles. So we are assuming that the north lines, these north lines are parallel to each other. Therefore, angle E and angle G are equal because these are alternate angles, and the line CD is the transversal. So in the equation we have E plus F, which is 97 degrees for 10 minutes and 49 seconds. But C in this case is equal to F. So these are alternate angles. And C, we have already determined the value of C. Therefore, to determine the value of E, we are going to subtract 97, because in this case C is equal to 67 degrees 44 minutes and 24 seconds. So to determine the value of angle E, we are going to subtract 97 degrees 10 minutes 49 seconds minus 67 degrees 44 seconds. 67 degrees 44 minutes 24 seconds. So the answer there is 29 degrees 26 minutes 25 seconds, which is equal to G. So since we've said E is equal to G, these are alternate angles and the north lines are parallel. So the value for angle G is equal to 29 degrees 26 minutes and 25 seconds. Now to determine the whole circle bearing of this line DE, to determine the whole circle bearing of the line DE is going to be 73, that is the internal angle, 73 degrees 36 minutes 08 seconds plus 29 degrees 26 minutes 25 seconds, and the answer is 103 degrees 02 minutes and 33 seconds. That's the whole circle bearing for DE. And now lastly, we need to determine the whole circle bearing for the line EA. That is the whole circle bearing on this line EA. We know that the whole circle bearing for the line DE is 103 degrees 02 minutes and 33 seconds, and we need to determine the value of H, this angle H, so that we can work out the whole circle bearing of the line EA. So this angle D, that is the angle D plus G is plus H is equal to 180 degrees, because these are allied angles and the north lines are parallel to each other. D is the transversal. So the value of H is going to be 180 degrees minus the whole circle bearing of the line DE, which is 103 degrees 02 minutes and 33 seconds, and this gives us 76 degrees 57 minutes and 27 seconds. Therefore, the whole circle bearing of EA is equal to 127 degrees, that's the value for angle E. 127 degrees 30 minutes and 19 seconds minus 73 degrees 57 minutes 27 seconds, and this gives us an answer of 50 degrees 36 minutes and 52 seconds. Now that we've calculated all this, we are now ready to determine the change in Hastings and change in Northing's calculations. So whenever we are calculating the change in Hastings and change in Northing's calculations, any line that has been observed, any line that has been measured in the traversal exercise is assumed to be the hypotenuse of that relationship between the change in Hastings and change in Northing's. So normally the Northing's, if we would want to work out the difference in the Northing sense or in the Y sense, these are known as the change in Northing. And normally the change in Northings, or we should say change in Northings, are determined by multiplying the distance of the traversal leg times its bearing. So as it is in this case, just in this portion, we have the bearing of the line, which is theta, the bearing of the line EA, which is theta, and the distance is 212.44 meters. So whenever we want to find the change in Northing, this line, this distance from here, A down here, the vertical distance, then we multiply this distance, which is 212.44 meters, times the cosine bearing, times the cosine bearing of this line EA. Then we are going to determine the change in Northings. While on the other hand, if we are determining the change in Hastings, that is from here to there, we work out, we multiply the distance, that the distance that we have observed in this case is EA, distance EA, times sine theta, or times sine bearing of the line EA. Then we have determined the value of the change in Hastings. So let us look at how we work out this. So we have in the previous example, let me show you again on that example. So in the previous example, anyways, okay, in the previous examples, you can see that we have the distance AB, which is 129.54 meters, and BC is 160.4 meters, and you have CD, which is 153.98 meters, and also DE, which is 193.40 meters, and then EA is 212.44 meters. So this is the column for the length in meters, and this is the column for the whole circle bearing. So the whole circle bearing of the line AB, of course 262 degrees, was already given by us, but we calculated these other whole circle bearings. That is, for the whole circle bearing for BC, we have 292 degrees 15 minutes 36 seconds, and also CD is we have 209 degrees 26 minutes and 25 seconds. For DE is 103 degrees 02 minutes and 33 seconds, and so on. So for us to determine the change in Hastings, like I indicated in that formula, so we are going to multiply the distance AB times sine of 262 degrees. I also demonstrated on how you punch in the degree symbols whenever you are calculating these problems from the previous slides. So you have this 129.54 times sine 262 degrees. So this gives us, to two decimal places, it's going to give us 128.28. That's the value for the change in Hastings. So these are in meters anyway, but it's 100, it's minus 128.28 0.28 meters. So the negative sign, it means that you are moving towards the left in terms of the eastings. And also the change in northings, so you multiply. I've indicated the formula here, that is we have d cos theta. So for d you substitute, you have 129.54, and then you multiply this figure by cosine 262 degrees, and the answer to two decimal places is minus 18.01 meters. So the negative sign indicates that you are going down the north. That is, in this case, the line may be slanting downwards, but towards the east, because we also have towards the left hand side, because we have minus change in eastings. So that's the minus symbol, indicates that you are going towards the west, or you are going towards the left. But if you are moving towards the right, then the value, whenever you are calculating, they're supposed to be positive. And for the northing, change in northing is supposed to be, when you are moving upwards, it's supposed to be positive as well. So you do the same with these other figures. That is, you have for BC we have 160.40. Then you say for change in eastings, you say 160.40 times sine 292 degrees 15 minutes and 36 seconds. This will give you 148 minus 148.45 meters. And if you want to determine the change in northings for the traverse leg BC, then it's going to be 160.40. Then you say cosine 292 degrees 15 minutes and 36 seconds. And this will give you a result to two decimal places, which is 60.76 meters. The same would apply to the distance EA. So for changing eastings, you say 212.44. For changing eastings, then you multiply by sine 50 degrees 36 minutes 52 seconds, and the answer will be 154.19. But if you multiply, if you want to determine the change in northings, then it's supposed to be 212.44, then cos 50 degrees 36 minutes and 52 seconds. Then the answer should be to two decimal places, that is, it should be 134.80. So since we need this in our next assignment, then since we need to correct it, that is to correct in the change in eastings, change in northings, and also possibly come up with the corrected change in eastings and also change in northings. Then thereafter the coordinates, therefore we need to determine the perimeter of the polygon that we have traversed. So we add all these traverse legs, and the answer is 849.76. And also we add the change in instincts and also change in northings. So wherever there are no errors, the answer is supposed to be 0. If we add all the change in instincts, the answer should be 0. But in this case, it's not 0. The answer is 0.19. So 0.19 is our error. And also for change in northings, we have minus 0.20. That is our error. So for us to eliminate those errors, for change in instincts, we need to subtract from the traverse legs, that is the change in instincts that we have calculated. We need to subtract 0, that is an accumulation of 0.19. Okay, that is the figures that we would have subtracted from the change in instincts. They should add up to 0.19. Therefore, if we add all the change in instincts, then the answer will be 0.00. The same would apply to change in northing, since we have short of 0.20. Therefore, we need to add to work out in such a way that we are adding 0.20, so that when we add all the change in northings, the answer is going to be 0.00. So we normally determine the error in each traverse leg by using the bondage method, which we are going to discuss in our subsequent discussions. So for today, maybe we should stop here, and then we'll continue in our next discussion by determining the correction in the change in these things and also change in others, and also how do we correct that, and how do we work out the correction using the bondage method. So thanks for your attention and listening. Until we meet next time. Thank you.